Welcome to Module 5, Lesson 20, Estimating a Population Proportion. Okay, and this will be the last lesson in this topic, and that's topic C, and then there will be three more lessons in topic D, and then you will be on to your end of module assessment. Okay. So in this lesson, we will continue using data from random samples to come up with estimates for population proportion. We're going to go ahead again and use the random number generator on the computer. And if you want to go ahead and pull that up again at that Ross-Mann-Chance random number generator, go ahead and do that. I will be using it next to me as well, and again, in your materials, or in my materials, your materials, there is the the random number generator, the paper and eraser type, but I was going to go ahead and just use the random number generator because it's just as efficient, if not more so, and it's all random anyway. So anyway, let's get started. Okay, in a previous lesson, each student in your class, and that was that last class, well, we didn't quite do this, but what we did look at is we looked at random samples from population and calculated the sample proportion. Okay, that was lesson 19. It was observed, of course, as we know, that there was a sampling variability to the sample proportions, as was noted on the dot plots and the distributions. We saw the variability right in front of us. And, of course, our important point here is the sample size increased, the variability decreased. Okay, an inverse relationship they have, we say. And again, let's write that down. I don't know if I've said this before, but they have an inverse relationship, this relationship between sample size and variability. Okay, as one goes up, the other goes down. As one goes down, the other goes up. Okay. So here, example 1, we have a class of 37th graders wanted to estimate the proportion of middle school students who were vegetarians. Each 7th grader took a random sample of 20 middle school students. Students were asked the question, are you a vegetarian? Okay, are you a vegetarian? That is a yes or no answer. Okay, therefore no numerical data is being collected, so we know this is, we're dealing with proportions here. So, one sample of 30 students had 3 students that said they were vegetarians. For this sample, the sample proportion is 1 out of 20, I'm sorry, not 1 out of 20, but 3 out of 20, or 0.15. Okay? Now, following are the proportions of vegetarians the 7th graders found in their 30 samples. Okay, so these were their 30 samples. Each of them sampled 20 middle school students. All right, and again, we talk about sample size. In this case, we know n equals 20. Okay, all right. The proportions are rounded to the nearest hundredth. Okay, and as we can see, the first student reported a sample proportion of 0.15, and that would be right here in that table of their 30 samples. So interpret this value in terms of the summary of the problem in the example. Boy, that sounds more complicated than it is. Simply means that 3 of the 20 students surveyed responded that they were vegetarians. Okay, so we just say 3 out of 20 said they were vegetarians. Okay, and again, this is all they can say they are. I mean, whether someone, you're taking a poll like this, survey, and there's always that risk that someone's not telling you the truth, or maybe a half-truth or something. Some people think they're vegetarians when they eat fish, okay, which they are not. All right, but anyway, yeah, so, they say garbage in, garbage out. If you get bad data, you're going to get bad results, but you can only trust people that they're telling you the truth. We've got to do that. at least. So anyway, 3 out of 20 said they were vegetarians. Now, number 2 here asks us, so it tells us here, this situation, another student reported a sample of 0.00, and you can see that right here. Now, the question here is, did this student do something wrong when selecting the sample of middle school students? Well, the truth is, it's pretty hard to do something wrong. I mean, you're just picking 20 people at random, unless you know that that you know beforehand everyone is a meat eater. Then you are kind of biasing. You're setting up your study for what we call bias, but no, nothing was wrong here. It just happened to be that no one was a vegetarian that he or she surveyed. So now assume you were part of this 7th grade class and you got a sample proportion of 0.20 from a random sample of middle school students. So based on this sample, what is your estimate for the proportion of all middle school students who are vegetarians? Well, that would be up to you, but if you took this sample, you might want to stick to your results and just go ahead with 0.20. They are 20% of vegetarians, and you could again, it's an estimate, it's a guess more or less. You're just basing it on your one sample of students, okay. But let's go ahead and construct a dot plot of the 30 sample proportions. So again, that's this table right here, okay, right over here. If you just go ahead and maybe either write those down or just pause, write those down, and go ahead and construct a dot plot, okay. And we know by now, we know by now what that is going to look like. Looks something like this, but I'm going to pause it before it populates. All right. So I created my graph, and it looks like that. Actually, I do. No, stop. Go back. Well, of course, you know how to do this. It's not that hard, okay? But yeah, go ahead and pause now. Go ahead and create your dot plot using that data. All right, and come on back. Okay, so maybe you're back now. I didn't even actually pause. Probably knew that. But anyway, here we go. I'm going to populate my, I'm sorry I'm using that word, but it is a good word to use. I'm going to populate my graph here, my dot plot, and there it is. And there is our distribution of 30 sample proportions. Okay, and those are the ones those hypothetical ones I put over there. All right, and if we went ahead and described this shape of this distribution, again, we're coming to see, and hopefully you're doing this yourself, and you are getting the same maybe same results. If you're actually pulling or polling, doing any kind of polling, that'd be kind of fun. You can't do your family; it's usually going to be too small. But maybe at a church, or maybe even at school when you come to school again, if you're ever out there, or maybe if you're a soccer player, maybe at soccer practice, go around to different teams who might be practicing in the same park. Take a little clipboard with you. Are you a vegetarian? Yes, no, pretty simple. Okay, and make sure they're middle school kids, because it kind of 6th, 7th, 8th graders matches what we're doing here. Anyway, that might be fun. Give it a whirl. Anyway, if we describe the shape again, it's got that kind of mound-like form. All right, low, usually closer to the x-axis at both ends, and sloping upwards towards the middle. Again, a very familiar-looking shape in statistics. Okay, for some very, very good reason. Okay, so if we go ahead and take the 30 class results, not listed above, not on my page, but on your page possibly. What is your estimate for the proportion of all middle school students who are vegetarians? Okay, and if you would explain your estimate. Again, once you pause, take a look at all that data, take a look at the dot plot, and make your and make your estimate. Okay, I didn't pause there either, all right? Anyway, I don't know what your estimate is. Since this is so nearly symmetrical, and I'm just looking at these. Boy, if I look right here, if I look at this, it looks like this 0.15, 0.15 here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got 11 dots over here, and 2, 4, 6, 8, then 9, 10, 11, 12, 13. I got about 14 dots there, right? If that makes sense? I'm not quite sure. That makes sense. That's 25, and then 26, 27, 28, 29, 30. No, it doesn't make sense. But anyway, but close. It looks pretty symmetrical. So if I chose somewhere around this 0, whoopsie daisy, if I chose somewhere around this 0.15, I might be happy with that estimate. Okay. Alrighty, so let's go ahead and, again, there's that data. I'm saying it's about 0.15, and again, if I look at it, I see quite a few 0.15s, all right? And again, we saw that on the plot, the dot plot, all right? All right, so let's go ahead and do this now. We're going to calculate a mean, and I know we talked about this being proportion, and now all of a sudden we're throwing a mean at you, okay? Well, it doesn't mean that you can't take a mean of a proportional data collection, proportional statistics, because the question was, the statistical question, the answer you got was either yes or no. It wasn't a number, it wasn't numerical, okay? But we can take those yeses and nos and add them up and then come up with averages or means, all right? So if you go ahead and do that, I'd love for you to go ahead and do that. Calculate the mean for these 30 sample responses here, and then come on back and let's see how close you got. Okay, so if I went ahead and added all of these up, of course, and divided by 30, I would have come up with an answer rounded to the nearest thousandth place of about 0.153, okay? So it is pretty clear that that estimate of 0.15 that I made, maybe you agreed with me, was quite a good one. You guys probably estimated anywhere between probably 0.10 to 0.15, and or maybe you did a little bit above. I'm not sure, but anyway, you might have been close. Hopefully, you were within maybe 0.05 of either of those. So anyway, let's continue on here. The proportion of all middle school students who are vegetarians, as we see now, is we're going to round it to the nearest hundredth. This is about 0.15. Now, it's very interesting, but this is the that's not the interesting part, but this is the actual proportion for the entire population of middle school students used to select the samples. Okay, so that's the actual proportion right there. Okay, when we took our samples, we were finding sample averages. Okay, how the mean of the 30 sample proportions compares with the actual population proportion depends on the student's samples. Okay, so you can see here in this case the mean of our 30 sample proportions is very close to the actual population proportion. So this number right here, this is an actual middle school where this data was taken from, and I'm going to show you a really neat website that I think you'll find really interesting, that deals with statistics and children your age. Anyway, they took this was an actual study that was done, and 0.15 was, and then in these 30 samples of 20 students turned out to be pretty darn close to the actual. Okay. Now, do the sample proportions in the dot plot, this is number 9 here, tend to cluster around the value of the population proportion? Are there any sample proportions far away from 0.15? Okay, if we look at that dot plot again, which is so very helpful, Well, yeah, there are. There's one right here that's pretty darn far away. Okay, right here, 0.00. That's pretty far. These are pretty far away from 0.15. Okay, so we do have that, but we do have a cluster around 0.15. But again, we have some variability. Okay, we have some variability present here, as we always do. Okay, so in this next example, it's going to be example 2. This example asks you guys to work with data from a middle school of 200 students. Okay, now although this school is fictitious, okay, it's made up, the data were obtained from actual middle school students and are representative of middle school students' responses. Okay, so a list of the entire 200 students' responses is provided at the end here, and I'll show this to you. You don't have this. Should have actually put it in your packet. Didn't think to, but here they are. These are 200 students responding to a number of questions. Okay, so there you see those are 5 pages. So all 200 students are represented there. Okay. What I find so interesting is that this data was collected from this website right here. It's called Census at School, right? And you can see the actual address right here. The URL is right down here if you want to go ahead and write that down and check it out. Really, really neat. What they do there is they actually have kids collecting data from their own schools. So you can see right here it says since that school is an international classroom project that engages students in grades 4 through 12 in statistical problem solving. Students complete a brief online survey, and then they analyze their class census results and compare their class with random samples of students in the United States and other countries. So that's really neat. If you have any interest in maybe pursuing statistics further or really learning more about it before you do venture into these classes one day, check this out. It's really neat, and you can create a project of your own. Definitely use our school to create a project. That would be super. So what we're going to do here is in this lesson, going to have you look at this this last question here. They had a number of questions that they had in this survey, and this last question here is, what superpower would you like? Okay, and the kids were given these choices: invisibility, super strength, telepathy, of course, reading people's minds, fly, or freeze time. And again, telepathy is to read people's minds. Okay, so these guys were asked this question, and now we're going to go ahead and talk about this and work with this data. All right. So we'll start right here. So 200 middle school students at Roosevelt, of course, fictitious Roosevelt Middle School, responded to several survey questions. A printed copy of their responses gave the various questions will be provided by your teacher. Okay, and those are at the end. Sorry I didn't give them to you, but they are at the end, and I'll zoom over to them and you can use them. All right, so the data are organized in columns and are summarized by the following table, and here they are. We had a column heading, so you can see there was the ID, and their ID was a number that was assigned to each student, okay, and that's numbers 1 through 200, okay, because there are 200 students. They asked them how they traveled to school, and there were some answers there. Methods used to get to school: walk, car, rail, blah, 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 blah. The favorite season of the year, of course, 4 choices there. Allergies, yes or no. Favorite school subject, all of those there. And favorite type of music. And as you can see, none of these descriptions here have any numerical data involved. It's all, well, except for the ID, of course, but it's only to assign a number to a student. The rest of it here, though, is all descriptions, yeses or nos, choosing from a list. Okay, so we are talking about working with proportions here. Okay, so now, as I said before, the last column, the data, which of the following superpowers would you most like to have? We're going to work with that, okay, from the class data. So the class wants to determine the proportion of Roosevelt Middle School students who answered freeze time to the last question. You will use a sample of the Roosevelt Middle School population to estimate the proportion of the students who answered freeze time. Okay, so we are interested in the proportion of students who chose freeze time. So freeze time is our focus, not necessarily interested right now with invisibility, super strength, telepathy, or flying. Okay, freeze time. All right. So we'd like to freeze time, like to stop time. That would be pretty cool. But anyway, all of those would be pretty cool in my book. Anyway, let's go ahead and get started. Okay, so here I am again at the Rossmann Chance random number generator applet. Okay, and the way I've set this up is I have number of replications 1, and then this here numbers per replication. This is we actually want that to be, well, hold on a second, let's go ahead and look at what they're asking us first. Okay, alright, so let's go right here. Okay, so a random sample of 20 student responses is needed. Okay, hold on a second. Sorry, I just can't read any of this. 1 second, I'll be back. Okay, let me start here again. So, a random sample of 20 student responses is needed. You are provided a random number table you used in the previous lesson. Okay, we're not going to use that random number table. All right, we're going to, again, use the random number generator. You can do this yourself, or you could just follow along with me. All right. So yeah, we're not going to do anything in small groups. Okay, so we're going to go ahead right now, and we're going to go ahead and select a random sample of 20 student responses, from the data file. Firstly, though, we need to select. Of course, the question here too is explain how you selected the random sample. We are going to go ahead and do this with the random number generator, again right here. Okay, and what I need to do is I have number of replications, that's going to stay as 1. Numbers per replication, I want 20. Okay, I want 20 responses here, or 20 different numbers. And my number range, of course, is going to be 1 to 200. Okay, because I have 200 different students. With replacement, this is going to be no. Again, if you're there doing this yourself, or you're going to do it yourself, I'd really appreciate that. Sort the results, I always do. It makes it easier to work with, okay? Then I'm going to hit generate, which I'm going to do right now, okay, over here on my other computer. All right, and I've generated some random numbers. Let's go back and plug those in here, okay? So my random numbers were, well, I'll write them down. I'll be back. Okay, well here are the numbers I came up with. These were the 20 student responses, or the 20 different students I generated from my random number generator. Okay, so there they are. And now what I'm going to do, and I'm hoping you can also do, is go ahead and locate these responses. So the way I would do that is I would go to these sheets here. Okay. And here again is the first one. This is 1 through 42. Next one is 43 through 82. Then I have 83 through 124, or 125, I guess that one was. And this is 126 through 166, and then 167 through 200. Okay, so I'm going to go back there. I've now flipped through them all. Okay, so you could go back and forth, reverse, rewind, and otherwise to actually work that yourself. So I'm going to go ahead and do that. If you want to go ahead and do that yourself, that'd be fun to see if we came up with the same replies. And again, these are going to be yeses or nos, all right? We're trying to find out. So for example, let's look at let's just do number, number 2 together. So we find number 2, here he or she is. I'll see there's no boy or girl here, is it? No. So he or she is, right? I'll take that off there. That is right here, number 2. And if you look at number 2, their superpower was telepathy, okay? And there you see telepathy. All right, so we would go back, and in this box here, we would put no, okay? Because student number 2 said no, all right? All right, so go ahead and do that, and come on back and see if our data agrees. Okay, well, this is what I came up with for my data. Not a lot of people, or not a lot of my randomly generated sample chose freeze time. Actually, only 1 right here, 1 out of 20. So if I find my proportion here, 1 out of 20, that of course equals 0.05, okay, or 5%. So 0.05. All right. So if we're going to estimate the population proportion of students who want freeze time by calculating the sample proportion of doing mine, I would estimate, and I think the way it worked out, I'm going to say that's going to be pretty close to 0.05 as an estimate for those from the population who chose freeze time. And again, my N was 20 students. Okay, this population, of course, is 200 students total, all right? Okay, so if we were in a classroom, we would combine our sample population with other students, sample proportions, and we'd create a dot plot, okay? But, of course, we're not in a, and again, this is about students who responded freeze time. Again, freeze time is our focus right now, okay? Well, anyway, I just used some data from the teacher's guide here, teacher's notes, and this is my dot plot I came up with here, and this would be mine, even though it wasn't mine necessarily, it was just someone else's that was there. Anyway, I was thankful that it was there to represent mine, because mine was 0.05. And again, this is surprising to me because my estimate was 0.05, but now, if I do look at the dot plot and freeze time, by looking at what is the value of the proportion of the students, I'm trying to think of what they're saying here. By looking at this, what do we think? Okay, so what do we think this is? What's a better estimate here? Okay, and that would be probably 0.20. I'm not sure the way this question is worded. It's a little bit confusing to me, this question here, but I guess we're trying to point to this idea. What is the value of the proportion who responds to a question? Okay. Anyway, I'm not sure what that question means. But anyway, the bulk of them seem to be right there, 0.20. Okay, so usually you will estimate the proportion, okay, using just a single sample of proportion. How different was your sample from the estimate based on the dot plot of the many samples? Okay, well, mine, as you saw, okay, was 0.05, and we're looking at about 0.20 here. Pretty far off. And yeah, so you can see the variability and the danger in using one small sample only. When you take those relatively small samples of 20 and multiply it by 30 different ones, you suddenly have a much larger population from your samples that you used. Okay? Okay, it says here, let me read this, I'll be back. Okay, so again, I addressed this number, this letter G here. It says circle your sample proportion on the dot plot, which I did, and how does it compare to the mean of all? Again, this was mine here, the 0.05, and it was far off. It was really far off. Anywho, H here, it says go ahead and calculate the mean of all the sample proportions. All right, and they're going to locate the mean of the sample proportions in your dot plot and mark this position with an X. Okay, so again, we're going to take all of this data here. I'm going to see if I can erase a bunch of this stuff so I can get some things out of the way. Let's see. All of this here, so make it a little bit easier for everyone to see. Okay, so let's go ahead and you do that, I'll do that. Let's calculate the mean from all of this data here. And just so you know, you're going to have 30 different data points. Okay, so just make sure you are, make sure you know that that is a point right there, 1 point for 35. Okay, all right, so you go ahead and do that, calculate that mean, and I will be back with my mean. Okay, so rounded to the nearest hundredth, I got 0.20 as the mean of that distribution, okay, of this fictitious distribution. If we had done this in class, it most likely would have been a bit different, okay, and even if I went ahead and generated another 29 different random samples, which I will not, I would most likely come pretty darn close to that. Okay, pretty darn close, it would seem. All right, here we are. Yes, at the lesson summary. The sample proportion from a random sample can be used to estimate a population proportion. Okay, the sample proportion will not be exactly equal to the population proportion, but values of the sample proportion from random samples tend to cluster around the actual value. Okay, well, that's something. That's a new point that they made here. All right, they didn't tell us again that the larger the sample size, the lesser the variability. But even in a small sample, a small random sample, responses tend to cluster around the actual value. Okay, cluster around the actual value, as we can see right here, a definite clustering going on, and we saw a lot of clusters from lesson 19 as well. Okay, somewhere within that, and it just makes good sense. Okay, hopefully you enjoyed this lesson. I did. We have that is the last lesson in topic C. I'm sorry. Next lesson 21, will be the first of 3 in topic D.